Oh boy. Okay, let's go for it here. So, last time we looked at plotting points, making sure they fall in a straight line. We had a very important word called collinear, meaning if points fall in a straight line, that means we could put a line through them. And we learned, and then we looked at three important straight lines. Let me just go back real quickly here, just to the previous section. We have just a line going through the origin. This is a straight line. We have a vertical line. I remember the formula for it is x is equal to some kind of number, and that number is wherever it hits the x-axis. And then you have the horizontal line. That is always with a y equals a certain number, and it's going to go across that number is where it hits the y-axis. Are we good? Those three important. We'll look at them quite a bit as well. So let me jump to this. Now we're going to look at something called slope, which, again, nothing new. For Math 61, yet, we'll get into some other little just notation stuff towards the end of the chapter here. But I think you guys have seen this here. If you guys ever drove on the California highways, you've seen something like approaching it's called a downgrade. Ever seen that before? 6%, 3% downgrade? No? Okay, cool. Got a couple of people here. Been on the road. Looked at signs. All right, just so you know, what in the world does this mean? So you can, as you look at some of it says a 6% grade. A 6% really what that means is how many feet you go down versus 100 feet across. So each time you go 100 feet forward, tells you how much elevation you have dropped. You can impress your friends with that if you like, next time you're driving. Okay, so my only question, the kind of fun one, is there ever such a thing as a 100% grade? Think about it for a little bit. Nick? Maybe? Gets us to the concept of slope here. So let's see, 6% grade means every 100 feet I go sideways, I'm going to go 6 feet down, right? So you guys tell me, what is a 20% grade? I could play the Jeopardy theme song. Dun, 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 dun. Let's see, a 20% grade, which we'll never see on the road. Would that mean for every 100 feet we're going to go 20 feet down? Okay, so let's keep on going with it here. 100% grade, what would that mean? For every 100 feet across, we're going to go 100 feet down, right? So 100% grade really just means it's like a 45-degree angle. Cool. So then if we keep on going, okay, how about 1,000%? That means for every 100 feet we go across, we're going to go 1,000 feet down, right? Again, trucks, cars won't be able to handle that, but I'm just sort of demonstrating a little something to you guys. So we have this number that gets larger and larger and larger, right? So 1,000,000% grade. That means you're going to go 100 feet across, and you're going to go 1,000,000 feet down, right? Eventually, this number is going to have to be sort of non-existent, right? So for a vertical line, if you're going to go straight down, there's no feet across. We good? So for a vertical line, there is no slope in a sense. So we call it no slope, or we call it slope does not exist, but there's really no number to capture a straight vertical line. Okay, good there? So we'll get to that here as well. But let's look at different types of slopes. Anybody tell me what page this is on in your textbook? 163. Perfect. Okay. Page 163. All right, so different types of slope. We have the negative slope, and the way we read graphs is from left to right, just like we read a book. And as you go from left to right, the graph is going down. Sometimes we say it falls left to right. It's falling down. The zero slope, what does that mean? It's going straight across, not going up, not going down. It's going 0 up, 0 down. It's flat. And then we got the positive slope. Think of it climbing a mountain if you like. But we have this as the rise on it. And let's take a look at the formula for it now. So all these different formulas here. Slope, the little symbol for slope is m. Because everything makes sense in mathematics, right? Slope, we'll use m. Just kidding, it does. Slope originated in the 1500s in France. The French mathematicians are the ones that sort of give you the calculation for it, and their word for slope begins with m. So hence, that's why it has an m next to it. We kept the variable, we just changed the name. Anyways, I think you guys heard of rise over run. That's a geometry form to it. The algebra form, this is the one we're going to be interested in, is really the difference between the two y values on top, the difference between the two x values on the bottom. And if you want to make sort of like a little, that's kind of what we do, sort of go backwards. You subtract y2, subtract y1 on top, and then subtract the x values on the bottom, which I think you guys know. Hopefully you know. But the one you want to write down is this one right here. So y2 subtract y1 divided by x2 subtract x1. Alright, so let's go for it here. We're going to sort of go backwards and forwards on it. So can we graph the line y is equal to 3x minus 5? Once we do that, then we can calculate the slope of the line. Alright, remember how we do this from yesterday? If we don't know what it's going to look like, all we do is we just plug in a little table. Now those of you that remember how to do this for Math 61, go for it. Something about an m, something about a b value as well. We haven't got there yet. We'll get there in the next section. Alright, so for us, I'm going to plug in the easiest number to plug in, which is 0. 0 times 3 is 0, minus 5 is a minus 5, negative 5. And we learned from yesterday, really the only other number, we just need another number, right? We just need another point somewhere. And since this is not a fraction, I can really plug in any number I like. Remember from yesterday's class, if this was a fraction, then we want to multiply by the denominator or a multiple of the denominator. In this case, I'm going to plug in a 1. Let's see, 1 times 3 is 3, subtract 5 would make a minus 2 or a negative 2. Alright, once we've got 2 points, we're good to go. So plug in 0, negative 5, 1, negative 2, and connect those dots with a straight line and then extend that line as well. Okay, then we want to go the other way here. Can we find the slope of this line now? Well, we're going to use this little formula right here. And the question is, do we already have 2 points to work with? Absolutely. So let's plug that in. It really doesn't matter which one's going to be your first point, which one's going to be your second point, but just let's decide on them. So 0, -5 is the first point, 1, -2 is the second point. And what this means is I need the y-coordinate of my second point. Okay, what I like to do, especially just to make sure I did it correctly, I like to put in the fraction bar, put parentheses everywhere. I know exactly what I'm plugging in where. So don't make a little mistake. So y-coordinate second point, that would be this one right here, that would be a -2. Y-coordinate of my first point, which is -5. Again, x-coordinate of my second point is a 1. X-coordinate of my first point is a 0. And we keep on going. Let's see, make that into a 5. So -2 plus 5 is a 3. 1 subtract 0 is 1, and then divide by 1 makes a 3. Good there. And yes, we see a little connection. This is made for the next section here, this little 3, and absolutely corresponds to this little 3 right here. That's going to be our slope. We just have to wait till the next section to get that. Alright, but let's work with this formula here. Let me give you 3 problems. It's not so much practice problems. They're more like one of each type. So first one's a pretty easy one here. Let you guys do this one yourself. I'm going to start it as well here. So the formula itself. And so y-coordinate of my second point. Again, put in these parentheses if need be. Put it in, so y-coordinate second point is -2. Y-coordinate first point is a 4. Then x-coordinate of my second point is a 1. And there it is, x-coordinate of my first point, 3. So how about a -6 on top, a -2 on the bottom, and then I get a 3 for my final answer. What? You waited for me to do it? You didn't do it ahead of me? Can't believe it. Alright, so notice also we're not graphing anything, right? We're just going straight to the formula. So no need to graph something if we don't have to. Alright. But I am going to show you the graph of it, just to sort of see it, just show what it's like. We should expect, because this is a +3, we should expect this going up from left to right. Is that correct? So let's just sort of see, just make sure. 1, 2, 3. 1, 2, 3, 4. So 3, 4 is about right there. And we got 1, -2, about right there. Yep, and that makes sense, right? We have a line that's actually pretty steep. Has a slope of 3. That looks like a pretty steep line there. Okay, example 3, and then we'll do practice problem number 3 here. I want to do the example because it gives you a different type of problem here. So example problem and the exercise problem, they're two different types. Maybe we should do both. So maybe use the back side of the printout or something like that. Might work. All right, I'm going to start it as well here. So formula again, if you need it, and putting in my parentheses and plugging in the values here. So it should be a 4, subtract a -1 on top, 3 minus 3 on the bottom, and that's our little problem. So if I put ++ on top, I give myself a 5, but 3 subtract 3 is a 0. And we all know, all the way from 4th grade, can't divide by 0. Therefore, you can kind of say it one of two ways here. You can just say the slope is undefined or undefined slope. Or you could say no slope. But of course, I'm curious. Now my question is, what kind of graph would give me a no slope or undefined slope? So I'm going to graph it real quickly here. 3, 1, 2, 3, -1, my first point. Then I have 3, 1, 2, 3, 4. Hey. Cool, so it's that vertical line. So a vertical line produces a no slope. Thinking about a road, then we think about a cliff. At that point, then you're really in trouble. Okay, cool. So vertical lines have a no slope. Let's jump to this one here. This is the practice problem number 3 now. Again, letting you try it yourself first. All right, let's go for it here. Formula again. And then we have a -3 on top. Also a -3 on top because it's the other y value. -1, subtract a 2. In this case, that should be a 0 on top. You're subtracting the same number from itself. And we got ourselves a -3 on the bottom and a 0 on top. We'll always produce a 0 as the ultimate answer for a fraction. Okay, so here we go again. Slope of 0. I think we already saw this before, is that right? Slope of 0 is produced by there's my 2, -3. There's my -1, -3. Alright, so horizontal lines are the ones that produce that 0 slope. It doesn't go up, doesn't go down. It's just flat. Okay, when do we use slope formulas? And what does it mean to do slope? What does it mean to actually figure out slope in the context of real world here? So here's what I got. This is a chart on page 162 in your book if you want to refer to it. But I have it here too. Whenever certain things are almost linear, what we do is we approximate it by using slope. Whenever a chart is somewhat linear. In this one, it's kind of linear, maybe. I mean, here's a big, humongous slope right here, but this is fuel prices. Could you imagine at 1955 we were paying like 40 cents for gas? That's kind of cool. I remember when I first started driving. I remember getting gas for like 89 cents at Arco. Like, yes, fuel up for a week. It only took me like 10 bucks. That's great. Not anymore, sorry. 3-4 bucks. And then you go to Japan, and it's equivalently, it's about $7 to $8 over there. So could you imagine paying that? Okay. The country's smaller, so maybe it compensates. Anyways, let's go for it here. So whenever you see data like this, sometimes we like to approximate it, and we do it by slope. Look, how fast is something increasing? So can you find me the slope of the point 1995? And 1995 is right here, and it says it was $1.25 here. And with the last point, so 2005, $2.93. Can you give me that slope there? After you give me the slope or the number itself, can you give me in a brief English sentence what does it mean? What does it mean to have that as that number as the slope? So I'll give you guys a little bit of time to calculate the number itself, and then see if you can write the English sentence there. Let's go for it here. So this is what I got here. I got 2005. Notice this is my second point. This is my first point. So $2.93. Subtract $1.25. And notice what's happening on the bottom. What we're doing is we're subtracting the years, right? It's 2005 subtract 1985. So let's see what this means here. Subtracting the top gives me $1.68. Subtracting off the bottom gives me 20. So then if I divide that, I get 8 cents, 8.5 cents about. Alright, this is the tough part here. What does 8.5 cents mean? It's not $8.04. This is, let's see, the dollars are here, so it's 0.0. This is 8 cents, and this is 4/10 of another cent. Ah, cool, yes. Remember, look at that. We're dividing by 20, is that right? So that means we're looking at something per year. Also is this whole concept right here. I'll just write it here. It's on average. Remember, this does not go up 8.5 cents per year. It's not a straight line going up. It's actually, there's a little dip right over here. 1995 looks like a low spot, and then it starts climbing up very quickly. So we say on average from 1985 to 2005, right? Because you have to get the years that you did. Gas prices rose by 0.084 cents. And then what Nick said, per year. So that's what a slope technically means. It's the average in change over a certain amount of period of time per year, or per unit of measurement that you're measuring.
So it's like in 20 years it went up $1.68. That's the price before you divided it?
Yep, so in 20 years it went up $1.68. So if you add $1.25 plus 1.68, you should get the 293. And we use slope formula a lot here. If you go into, again, like in nursing or something like that, you have assimilation rates. How much of whatever drug you've given, how much is it absorbed into the body? There's a slope for that. And how fast does it do it? Ever went to the dentist and the dentist gave you or prescribed to you pain medication, and usually they say take it every 2 hours. How come the 2 hours? It's because there's that assimilation of your body. After about 2 hours, then it starts going out of your body at this point. Then you need to sort of keep it on high every 2 hours. That's why. So, and then, of course, then you have stronger medication. Then you get to the point that you have a morphine tablet you take once a day, and that's all you need. Whoa. And then you got patches now, yeah. So all this stuff, again, all based upon this sort of whole concept of slope formula, how much assimilation, and how much time it takes. So, yeah, slope are pretty important here. Okay, another little example. So an object is traveling at constant speed. There's an important word there. The distance and time data are shown on a graph below. And then use the graph to find the speed of the object. So here's what I want you to do. And this is the whole this little thing right here, constant speed. Notice, hey, all these dots, aren't they collinear? Don't they fall under the same exact line? So here's what I want you guys to do. Pick any two dots. It doesn't matter which ones. So we're getting another concept here. You can pick the 0, 0, you can pick the 145, you can pick the 225, the 180. Pick any 2 points, and let's get a slope off of those 2 points. And just another little concept of slope. I'll give you guys a little bit of time. So here's the concept here. Hopefully you guys use different numbers. Anybody used 225? Okay, got a couple of people here. How many used 0, 0? It's one of their points. Nobody used 0, 0? 0, 0 is the easiest one to use. Okay. I did the 225, and then the 180. So if you do that, hey, you get something called 45 miles per hour. Is that right? And whatever you used, you should have come up with still 45 miles per hour. And so this whole concept of slope, as long as this line is straight, as long as the points are collinear, it doesn't matter what points you choose, we will all get the same exact answer at the end. Cool. So the slope really is that steepness of that straight line. And if the steepness of the straight line does not change, therefore any points you choose would be okay. All right, and another concept of slope, again, we're just sort of rehashing things from Math 61. Concept of parallel lines and perpendicular lines. This is the way the book does it. Anybody know what page number we're on? Awesome, okay, cool. This is the way the book says it. I don't think it says it quite right. I would rather write it in English here. So let me write it in English. I would say parallel lines have the same slope. If you want to sort of write it in the English form. All right, and then for perpendicular lines, they have the proper calculus definition for it. I don't like this definition here because we don't know how to get to it. It says this: if you have two perpendicular lines, if you take their slopes and multiply them, you will get an answer of -1. The problem this way is that for algebra, we're going to have one line and we're going to try to get the slope of the other line. So you're not going to have both of them. So a little bit better definition for it is perpendicular lines have opposite reciprocal slopes. So opposite meaning you have to change the sign, and reciprocal means we're going to flip the numerator and denominators. So you got to do those two things there. And of course the parallel lines, that's the easy part. You know, once you know one slope, you know the other. That's not really anything to work with. But let's work with the perpendicular lines here. How do you get an opposite reciprocal, or how do you get a perpendicular slope if you know one of the slopes already? Sort of like that, yeah. Let's jump to it. So number 6. So find the slope of any line that's perpendicular to a line that goes to these 2 points. So first and foremost, we've got to get the slope of the line that goes to those 2 points first. So let's go for that. So we've got to get a slope here first. Cool. And I wanted you guys to try it first here. I got 5 subtracting -3 on top. 6 subtract 2 on the bottom, which gives us a +2. All right, so that's the slope of the line that goes to these 2 points. What I want is I want the perpendicular slope. So all we're going to do, since this is a positive, we're going to change it to its opposite, which is a negative. Since it's a 2, we're going to take a reciprocal of 2. Everybody okay with the negative 1/2? Too easy, I understand. Okay, for the matched problems, if you take a look at the number all the way in the back, you'll see that it's incorrect. I think they put a positive 1/2. That's not good. Okay, but real quick here, what does perpendicular lines mean? What do they actually mean here? So the blue line and the purple line, those are considered perpendicular lines. They're lines that intersect at exactly 90-degree angle. That's what perpendicular lines are graphically. Okay, and again, once you know the slope of the line you have, once you know the slope of the perpendicular line, here's our little definition. Remember, if 2 lines are perpendicular to each other, if you multiply their slopes together, you would get a -1. That's sort of the proper definition. And again, I don't like that because in algebra, the way it's going to happen is the first way here. We're going to know some kind of slope, or we're going to try to find what the perpendicular slope is. Okay?
So if it was like 4, it would just be -1/4.
Mm-hmm.
So it's always just -1 over whatever it is.
The question is it always negative? It's not always negative, it's just always opposite. So if this was a -3 on top, then it would be a positive 1/3 on the bottom. So opposite signs and reciprocal. Okay. That was 3.2. Jumping to 3.3. Finally, we get to the point of the fastest way to graph. Alright, some of you guys know this from Math 61. Some of you guys are very familiar with it. We call it the SlopeIntercept Form. SlopeIntercept Form used quite a bit. As long as you have something solved for y, all we need to know is what our slope is, and the slope is the number next to the x variable, and then we need to know the y-intercept, so we label it as b. Alright, and again, why do we label it as b? You know, all the curiosity here of everything is because when you go back to this, remember y is equal to b? That was already our y-intercept from 3.1. So the whole concept of just let's use the same exact symbols for each one. Alright, so we need the slope, we're good. We need the y-intercept, and we're good to go. So if you can graph it, they want you to find the equation first. Can you set up the equation based upon the slope of 2/3 and the y-intercept of 1? Once you've stated the equation, then can you graph it? Okay, why is this such a fast way? Is because you technically don't need to write anything down except for the graph. But of course, we're going to make you write stuff down. But if you're doing it on the homework, you should be able just to look at the numbers 2/3 and 1, and you're done. So remember how we used to do intercepts? You had to write down the 0, you got to get to the other point. Right, this is even faster because you don't even need to do that. You just need to know some numbers here. Okay, so let's go for it. What does the equation look like? It's like this: y is equal to, that slope goes right in front of x. It's the multiplier to the x variable, and the y-intercept is the number by itself all the way at the end. What does the slope mean? What does the 1 mean? So the y-intercept, again, along the y-axis, if I were to find the 1, there it is. There's my first point for this graph. The slope, I'm going to write it off to the side here just real quickly here. The number on top tells you go either up or down. Because it's positive, we're going to go up. Number on the bottom, it tells you to either go to the right or to the left.
Right.
But it's going to go to the right, and most of the time we're going to go to the right, because remember, with negatives, we don't like to keep negatives on the bottom of fractions. We like to bring them up to the top. So from this point here, we're going to go up 2, 1, 2. We're going to 3 over to the right, 1, 2, 3, to find our second point. Once we've done that, we are done because we connect them with a straight line. Put arrows at the end, don't forget. Alright, and of course a little trivia question. Math trivia here. Tell me true or false. What do you guys say? Is this true or false? How many say false? Mr. 8, it's false. Can't trick Math 63 students. 61 I can. Okay, so it is true. 2/3 is the same thing as negative 2 over negative 3. And you can even show it on a graph here, because if I were to graph this, I would go down 2, and then I would go left 3. So notice real quickly here, if I take this dot here, and I go down 2, and I go 1, 2, 3, notice I'm still on the line. In fact, I can do this forever, is that right? I can go down 2, 1, 2, 3. It should have been about right here. I'm off a little bit on my line. But you can keep on doing this forever, and connecting more and more points. Okay, the only problem is many times it's not set up like this. Not set up as y equals something already. So if it isn't, then what we have to do is we have to solve for it. So can you solve for y first? Once you solve for y, not going to make you graph it, but just tell me what's the slope and what's the y-intercept, or what's the m and what's the b. Alright, let's go for it. So in order to solve for y, how about we subtract 4x from both sides? The negative 5y stays, and then what we want to do is we want to put the negative 4x first, because we want to look like just like mx plus b, the number with the x first. Divide through by negative 5, and again a little bit tricky for some here. I would divide each of those pieces by negative 5. And so then I'm left with a positive 5/4, so it was our 4/5 x. How about minus 7/5? And bless you. Alright, so the slope is 4/5. The b value is negative 7/5. The sign goes with the number. Alright, the reason why we say this is the fastest way to graph is because many times you will have it solved for y. In fact, when we get to 3.5, we're not going to call this y, we're going to call it f of x, because it'll be a function. Once you define a function, this will be defined as a linear function. So we use this quite a bit to graph. Okay, so let's do the whole entire thing here, beginning to finish. Can you solve for y? After you solved it, can you graph it? Alright, I'm going to start as well here. So solving it for y, I would have to add 3x to both sides. Then divide by 2 on both sides. Each of those pieces being divided by 2 gives me 3/2 x minus 3. See people shaking their heads. Yep, so that's what they got. Good. And then let's graph it here. So the negative 3 is where we go find it on the y-axis. So negative 3 would be about right there. Okay, this means 3 up. And that means 2 to the right. So 1, 2, 3 up, 1, 2 to the right. There it is. And again, connecting it, extending it, put arrows at the end. We're good to go. A few things to note here. If we were doing it by intercepts, remember intercepts, we would have got these 2 points just by doing it by intercepts as well. So there's really no difference there, which way you do it. In general, this is sort of like a very in general statement. If you have x and y both on the same side, we normally do this by intercepts. So if we see x and y adding or subtracting to give you a constant. I would probably do this by intercepts. If it's y is equal to, if it's in this form right here, normally we use it y equals mx plus b. So it really depends which form it's in when it's given. Now, can you change it into the other form? Absolutely. We just did that right here. That would be more like an intercept form. Solved it for y real quickly here, and then graphed it. So whichever choice you prefer, you're going to get the same exact graph, so it's okay. Alright, since we did it this way, now let's go backwards. So something called the point slope form. So we know how to go from equation to a graph. Now the question is, how do you go from graph back to an equation? Alright, and it does come from the slope formula. If you think about it, if you divide both sides right here, notice you get the m times x minus x1. If you divide this guy by x minus x1, divide this by x minus x1, don't you get the slope formula? So it's sort of like a little bit of a slope formula in here. Okay, but what is this form used? This form is used to get the equation of a straight line from a graph. So this is the backwards way here. So let's go for it. Let's use some examples here. So I need to find the equation, and once you say find the equation, you're thinking point slope form. Da-da-da. I need to find the equation of a line that has a slope of 3 and then contains negative 1, 2. Eventually we want to write our answer in SlopeIntercept form. So once you say find the equation, in my mind this is what pops up right away. And let's start plugging in the values here. So any time you see the y and the x, those are just variables, nothing to plug in. And then when you get to the y1, it's this point right here. It's the y coordinate equal to what comes in for m? 3 is good, yep. X is the variable in the beginning. In this one, the quick way to do it, if you're subtracting a negative 1, it's really the same thing as adding a 1. So let's put in the opposite sign right away. So we'd have to rewrite it all over again. Some people are done already here, but this is a two-step process. You distribute the 3 times x and 3 times 1, and then we do whatever we need to do here. Add or subtract. In this case we're going to add 2 to both sides. And we solved it for y. That is SlopeIntercept form. Real cool. Hey, and again this little matchup here. Notice it says slope of 3, and then we got ourselves a 3 times the x. So it does work. The slope is the same here in both instances. Okay, sometimes you look at a graph, you know the slope of it, you know the points that it goes into. Sometimes if you're looking at a graph, you only can see what 2 points they cross. So this point, exact same problem, except we don't have a slope this time. I know it goes through 2, 5. I know it goes through 6, negative 3. Alright, so again, since I only know 2 points, hey, if I know 2 points, can I get the slope though? Absolutely. I've got this little slope formula, don't I? So besides like number 4, the only thing is we have this extra little step. We're going to find the slope ourselves. And so negative 3 subtract 5 on top, 6 subtract 2 on the bottom, and how about a negative 8 divided by 4, or a negative 2? Alright, once you get to this point, now I have a slope. That's awesome. And actually now I have 2 points. Alright, which one do I use? Use 2, 5. I can use either one, right? Because 2, 5 is on the line. 6, negative 3 is also on the line. But I probably choose 2, 5 just because there's no negatives there to deal with. And I'll let you guys finish it off. Alright, plug in the values here. Again, you could have chosen to put in the 6, negative 3 if you wanted. I put in the 2, 5 coordinate, distributing the negative 2. Gives you negative 2x plus 4. And then adding 5 to both sides gives you a constant of 9 at the end, but y is equal to negative 2x plus 9. Is that good? I guess I should say, is that what you guys got? Alright, so this is called SlopeIntercept Form. SlopeIntercept Form, y is equal to something, and the formula is given on this side. But remember that we sometimes are given x and y both on the same side? There is a little special form to it, and it's called the standard form. Standard form is when you have x's and y's are both on one side, and you just have the constant term on the other. We use this whenever we do something called matrices, whenever we do systems of equations here. I used to teach the business math class after Math 63. I used to work at a different college, and literally the whole class is based upon this right here. This whole concept of getting your variables x and y on one side, and we got to the point that we had to plug into Excel spreadsheets, and we figured out probability. So the weather forecast says it's going to freeze. We have oranges that are might be freezing as well, and that's not good. Should we turn on the electric pump to run the windmill? That's all a probability. That's all based upon this right here. It's all based upon percentages. Kind of fun little class there. Okay, so here's what we're going to do. We're going to do the problem that we did similarly last time. It says find the equation of a line that goes through 3, 2. Ooh, is perpendicular to this guy, and when we're all said and done, we want to write our answer in standard form. Oh man, let's go for it. So find the equation of a line that goes through 3, negative 2. Oh, I got my point. I just need my slope now, and the slope is going to come from being perpendicular to this graph over here. Well, we have our point here. It's just about getting the slope. So let's get the slope. First of all, let's get the slope of this line over here. Let's go with subtracting 3x from both sides over here. That's a negative y is equal to negative 3x plus 2. The y is almost solved for. Let's divide through by negative 1 or multiply through by negative 1, whichever you want to choose. And I think what I got myself is a positive 3x minus 2. Okay, so 3 is the slope of this line. If I want the perpendicular slope, what's the slope that I want for myself? Yeah, we need opposite and reciprocal, right? So since this is positive 3, we need a negative. This is 3, take the reciprocal, we get ourselves a negative 1/3. Got myself fractions to deal with here. That's not cool. That's okay. Now can you plug into this formula right here to finish it off? So the slope that I have is negative 1/3. Goes through 3, negative 2. I'm sorry, 3, 2. At the end, can you give the answer in standard form? Alright, plugging things in here. Looks like a 2 goes in for the y1 value, the negative 1/3 for the m, and a 3 for the x value. And again, this whole concept of multiplying through or distributing the negative 1/3 gets you negative 1/3 x. And then let's see, negative times the negative is a positive. And 1/3 times 3, it's a 1. The 3's will cancel. Ooh, a little bit different now here. Because we're not trying to solve for y, right? If we were trying to solve for y, we would Add 2 to both sides. Ah, make you guys erase. Caught you guys. Good. Love it. Okay, so in standard form, one of the things in standard form is that we don't have any fractions. There are no fractions on standard form. So to get rid of our fractions, we multiply through by any common denominator. In this case, it's going to be a 3. So 3 times y, 3 times a negative 2, 3 times a negative 1/3 is a negative x, and 3 times 1 is 3. So got rid of all fractions. Next step is to get our x's and y's all on one side, all by themselves, and our constant terms to the other side. Let's do the constant term to the other side. Let's get rid of the 6. Let's bring the 6 over this way. So let's add 6. That makes 3y is equal to negative x plus 9. Let's get x to the other side now. Adding x to both sides. Those are not like terms, so therefore it'll be x plus 3y is equal to a 9. Notice now x's and y's on one side, the constant term on the other. Your book doesn't mention this for some reason, but a few more things happen with this here. First of all, most algebra textbooks don't like the number in front of x to be a negative. So if you see a negative x over here, we normally just multiply through by a negative as well. So most algebra textbooks want the number in front of x to be a positive number. And the other thing is something called relatively prime. If you can divide a number into all 3 of these numbers here, you should. Let's just say theirs was like a 6 right here in front of x. So if you see a 6x plus 3y is equal to 9, you know you can divide all those pieces by 3. So you want to sort of get into the most lowest terms possible in that way. Okay, we're good? Your book, I think it accepts both a negative and a positive in front of x. So it's okay. On the test though, since I'm only looking for one answer, I'll just go with just the positive in front of x as the answer. Okay, and then there's a little summary here right at the end of this section. Same stuff that I had before, except additional things here. So not just the equation here, but now you have the slope, you have the x-intercept stated, the y-intercept stated. So what page is this on? 182. Awesome, thank you. Again, refer back to that. That may be something you want to look at in order to make up your 3x5 card eventually. The only thing that's not stated here are all the formulas that we just covered. And that stuff you should write SlopeIntercept Form, Standard Form, Point Slope Form. Those 3 you still should sort of go back and cover just to make sure you got it.